Welcome back to the Introduction to Viscore video series. This is video number 3, which is a tutorial on how to load your own data. This video assumes you've already successfully installed Viscore, so if you need help with that step, go back and look for the first video in this series, which is called Getting Started. Another prerequisite is to have Agisoft Metashape software and a project installed, which has been processed through at least the step of generating the dense point cloud. If you don't have the Metashape software or a project ready, but you do have some other data that you can convert to a .ply format, this could be a LiDAR or a multi-beam point cloud, for example, that's an okay way to get going. You can actually follow along the first half of this tutorial in that way. It's really just the second half of the video in which we focus on ingesting the raw images, which is where you'll really need Metashape and a project. So note that, as usual, I'll display the keys and buttons that I'm pressing in this box in the upper left corner of the screen in order to reinforce the instructions. Okay, let's get going. The first step of the process of importing your own points is to place your point cloud in a .ply format. .ply is the polygon file format, which is otherwise known as the Stanford triangle format. I'm going to start by showing how to make a .ply from an Agisoft Metashape project. Let me start by showing you how I organize my data. The demo dataset we'll use today is an Acropera server restoration site off Key Biscayne, Florida. I keep my raw images separate from the Metashape and Viscore projects, or any other sort of analysis. So here I have all of the raw images in a folder called Acer Data. You can see under here a folder with the site name, Plot NFL, and 2 subdirectories, one for each camera. This was a site where we acquired data with a dual SLR camera setup. Under Acer Processed, there's also a folder with the site name containing the Metashape project, plotnfl.psx. Start by opening up your project. In here, you can see I have all the normal things you might expect. The original matched tie points, the dense cloud, a digital elevation model, an orthomosaic, some scale bars, very typical items you'd expect to see in a Metashape project. Now I have to emphasize a very important caveat regarding scaling. If you scale your models within Metashape, this information needs to be discarded before exporting to Viscore. What do I mean by scaling? If you've used known targets to create a scale, or if you've georeferenced your site with real-world coordinates, say by using a GPS, then you have scaled your model and you will need to discard that before exporting. As you can see in my project here, I have several scale bars and I've computed a DEM and an orthomosaic. So I need to remove this before exporting the points to Viscore. There are at least 2 ways to proceed in order to discard the scaling data. The conservative method is to make a copy of your data. Right-click on the chunk and select Duplicate. You just need the depth maps and the dense cloud, not the DEM or orthomosaic. I suggest renaming the duplicate chunk something obvious like chunk 1 copy no scale, but you can pick whatever you like. Next, right-click on the chunk that you just duplicated and click Reset Transform. Now, export the points in this duplicate chunk using the following technique. Just right-click on the unscaled dense cloud, click Export Dense Cloud, pick the Stanford PLY option, and give this file a name. I usually just use the same name as the Metashape project, but with a .ply extension, so plotnfl.ply in this case. Then there are options you want to pick. Save the point colors, save the point confidence if in fact you computed confidence bounds for your point cloud. Save the point normal, save point classes, convert to 8-bit RGB with binary encoding. Finally, check the coordinate system. It should say local coordinates meters. If it's grayed out like it is here, then you're all set. But if you have georeferenced your model to UTM or some other coordinate system, then you need to reset it here to use local coordinates. Finally, click OK to start the export. Once the file is exported, you should find the .ply file in the same folder as your Metashape project. Okay, that's the conservative way to remove scale. But you can also just follow those same steps on the original chunk. Just be careful. Do not save the project after you reset the transform. So after exporting, quit Metashape or select Start a new project without saving the project. That way, your scale will remain in the project, but it will just be omitted during the export process and will be omitted in the exported .ply file, but it won't be lost from the project itself. Either way works. It depends on your preferences and your sort of workflow and risk for tolerance, or tolerance for risk. Once you have a .ply file, it's worth thinking about organizing your data. The Viscore dataset consists of multiple files and subdirectories, as we learned in our last video. So what I like to do is to create a separate folder to contain all of this stuff. Here I have the folder aser processed, which contains my Metashape project. So I'll make another folder, aser viscore, to contain the Viscore dataset. You can name it however you like or put it on a different drive. Just come up with a naming convention that works with your workflow. Next, drag the .py file into this new folder. I'll call that the Viscore dataset folder. In a separate window, navigate to the Viscore installation directory, c/vid. In there, you'll find 3 batch files, vcprep-confidence.bat, vcprep-goldeye.bat, and vcprep-goldeye-slowply.bat. These do the importing. Use the confidence one if you had computed the depth confidence intervals when making your dense cloud, or use the others if you haven't. To start the importing, simply drag your .ply file onto one of these 3 batch files. When the importing is done, you have a minimal Viscore dataset, which is one .vml file, the project file, and one folder containing the points indexed in a structured way. Note that the name is the same as whatever you called your .ply file, so think carefully about that. When you double-click the .vml file, Viscore opens, and you can see your point cloud. When you open a new dataset for the first time in Viscore, initially the points look like big blobs. I mentioned this in the previous video about the Viscore interface. This has to do with the size that the points are being displayed. You can and should change this with either the control key/scroll wheel method or with the visopt toolbox and then changing the point size parameter. In general, the first 2 things to do with a new dataset are to set the point size and then to set a view that you like and then update the default bookmark. Remember to update the default bookmark, click Edit, then Overwrite, and then OK. After updating the default bookmark, you won't have to reset these things again the next time you open this dataset in Viscore. Viscore can and does work with any point data, so what I just showed you will work for multi-beam or LiDAR data or photogrammetric point clouds, output as .ply from any software. Viscore is, however, particularly well integrated with Agisoft Metashape in the sense that it can import the positions and projections of the original photos as determined by Metashape. To do this, run the script extract_meta.py, which is found in c/vid/setup. Go back to your Metashape project. Make sure to select the unscaled chunk or remove the transform for the single chunk as we discussed before. Then use Ctrl-R as a shortcut or click on View, Console, then click the arrows, the 2 arrows button. Either way, you'll pull up this Run Script dialog box. Under the script line of the dialog box, find the c/vid setup extract_meta.py. There are no arguments. Just click OK. Some data will scroll up in the console, and you'll get 2 new files in your directory containing the Agisoft project. Project name, project.cams.xml and projectname.meta.json. Move these out of the Agisoft project folder into the Viscore dataset folder. Now start Viscore again. Turn on the Cams toolbox. Left click or scroll on None to activate the cameras. By default, it shows the path that the cameras took. You can switch this off and show the camera locations for each picture as dots, or some combination of both of those. To drape the original raw imagery onto the point cloud, click Drape On. Then, double middle click at some point on the point cloud. The image with the center closest to that point will be displayed on top of the point cloud. Note that the point cloud will be rotated to orient so that the top of the image is facing up on the screen. At this point, you can use F12 to toggle between a spotlight view of just a portion of the selected image or the entire thing. Whichever mode you're in, holding down Alt temporarily shows the other mode. So if I'm in Drape full image mode and I hit Alt, I temporarily see the spotlight. And if I F12 to spotlight mode and I hit Alt, I temporarily see the whole image. You can hold down Control and use the arrow keys to step along through the sequence of images. Draping the images is cool, but there's an even more powerful way to view them. The linked images can also be viewed in a separate window called an image viewer, or iView, rather than draped on the point cloud. It's most convenient to have a second monitor to do this, but you can also toggle between multiple windows, desktops on the same monitor. To start iView, keep the cams on, drape set to off, and open a web browser. Point the browser at this address, localhost:9090/JSD/pq.xhtml #0. As an aside, obviously it's handy to bookmark this address if you're going to be using Viscore at all often. You'll see when you first open iView, it will be waiting for input. The image viewer is triggered by placing a marker on the point cloud. To place a marker, use Alt plus the middle mouse button click. The image closest to that point will open in the iView window. You can see a red dot in the iView window corresponding to the point where you put the marker on the point cloud. If no image appears when you place a marker on the point cloud, make sure Cams is turned on and the cameras for your dataset are selected. Here it says Plot NFL. If it says None, scroll or use the left mouse click to turn on the cameras. The iView window is awesome. It shows the point you selected placed on the closest image to that point. You can use the scroll wheel to zoom in and out, which really lets you access the full resolution of the raw imagery. You can use the left mouse button drag to move the image around in the window. You can also use the right mouse button drag to rotate the image within the window. Most excitingly, you can also see all of the images overlapping that point. If you look down in the lower right corner, you'll see the count of all overlapping images and the file name of the current image. You can hover over the left number and either left-right mouse click or use the scroll wheel over that image number to flip through all the images overlapping that point. This really helps if one image is blurry or if you just need a different view of that point. The keyboard shortcut for this is a right mouse button click, hold it down, and rotate the scroll wheel. This is a much faster way to flip through the images without having to hover over the number. To move the marker on the point cloud, use the right mouse button drag in the viewer window. The images in the iView window will update to follow the marker. You can also move the marker in the iView window if you double left click on the image there. Whichever way you move the marker, the changes will be reflected in the other window in real time. It is possible to have multiple markers and move among them. Go back to the viewer window, Alt middle click to place a second marker. Notice that the information about this new marker shows up in the HUD. The trick to switching between the markers is to make sure that none are selected. Click None on the HUD. And then left-click the one that you want to view. If you want to switch, make sure none are selected, and then pick the other marker. Note, if you lose your markers, if you lose track of them, you can click Control-A, which will select all of them, and this makes it easy to find them, and then click None, and then click the one you want. Importing point clouds and images becomes second nature after a few tries, but sometimes things do go wrong. There are a few common pitfalls, and I want to show you what those look like and how to fix them. The first common problem is when the point cloud you were expecting is surrounded in space by a crazy array of colored dots. You can see in this example that the data are there, but a bunch of extra points are scattered through space. Most often this is caused by using the wrong import script. So exit Viscore, delete all the Viscore files except the .ply, and try one of the other three import batch files. vc5 prep-goldeye-slowply.bat in particular does some extra error checking and is a good option if you have this problem. If that fails, the problem is probably with the exporting. Try re-exporting your point cloud, paying particular attention to making sure the data are unscaled in local coordinate system and the export confidence option is checked or unchecked appropriately depending on whether you computed that or not. The second common problem is when the image tracks don't align properly with the point cloud, as seen here. This also is caused by running either the export to .ply function or the extract meta.py script on scaled data. Usually the problem is a .ply file that was exported with scaled data. Try re-exporting the point cloud, making sure it was properly exported as unscaled, and then remove the datasetname.meta.json and datasetname.cams.xml files, there are several of those, from your Viscore project. Then make sure your data are unscaled and try it all again. A third common problem happens when you have multiple cameras in the same dataset. Normally, two cameras on the same platform should produce two parallel tracks, but if they look like a big spider's web mess like this, you can solve that in Metashape with camera groups. When you're making a Metashape project with multiple cameras, put each one in its own camera group. To make a camera group, right-click under Cameras and click Add Camera Group once for each camera, and then drag the images for each camera into the appropriate group. Then, when you run extract meta.py, the cameras will form separate tracks. Remember this for future projects because it might be a lot of work to go back and correct after you've already computed matches and a dense point cloud. Finally, there's a common problem when the raw images are moved from the directory where they were when extract meta.py was run. To simulate this, I'm going to rename the directory containing my raw images from aser data to aser data moved. Viscore is expecting to find the images in aser data, but now they're gone. The presentation of this problem will be when you turn on cams and try to drape images, you'll get a sort of checkerboard pattern instead of the image itself, plus the message image missing in the lower left under the cams toolbox. To fix this, all you have to do is find the new location of the data and then drag and drop any image in the dataset into the Viscore window. You can see when I do this, the image missing messages goes away and the checkerboard pattern turns into a projection of the actual image, and the problem is solved. Okay, as we've seen, viewing in the iView window or draping imagery on top of the point cloud involves a bunch of new mouse gestures and keyboard commands, and so I'm just placing here a small summary to remind you of what we've gone over. You could screen grab this or something, keep it handy as you're learning how to use the CAMS tool. And in closing, I guess I'd like to share a few acknowledgements. Of course, Viscore was developed at the UC San Diego. Please cite this paper by Petrovic et al. If you use it. Support for this video series was provided by NOAA's National Oceanographic Partnership Program and the Pew Fellows Program in Marine Conservation at the Pew Charitable Trust. Hopefully this video gave you some skills to start interacting with Viscore with your own data. Look for more videos in this series to learn how to analyze and extract important information and use your data set to the fullest. See you next time. Thanks for watching.